Everyone, welcome to the webinar. I'm just getting everything started here. And tonight, I decided that instead of interviewing someone local, what I was going to do was present a speaker that I think we all should start listening to. He is one of the top researchers in anti-aging, and I think you'll really get a lot out of this, so hang in there with me just a second, and I'm going to pull this up.
Let me start with a question. Please raise your hand if you want to get Alzheimer's disease. Please raise your hand if you think that you will want to get Alzheimer's disease at the age of 90. Even better, even better, even better. The first thing I want to explain to you is the relationship between the diseases of old age, things like Alzheimer's, and aging. Essentially, let me start with a question. Please raise your hand if you want to get Alzheimer's disease. Please raise your hand if you think that you will want to get Alzheimer's disease at the age of 90. Even better, even better, even better. The first thing I want to explain to you is the relationship between the diseases of old age, things like Alzheimer's, and aging. Essentially, what I want to tell you is that you should not really pay any attention to anybody who uses the word aging without really explaining what they mean, because they almost certainly don't know what they mean. It's an extraordinarily poorly used word. People can say the most ridiculous things when they think they are understanding what aging really means. I'm going to tell you what I mean by aging, and that's what's going to be the basis for everything else I say. Aging is a process that goes on throughout life, even starting before we're born, and it is simply the accumulation of damage in the body, in the human body or in the body of any other living animal. Aging is initially harmless. That's why those of you who are 40 years old are still working pretty much as well as those of you who are only 25 years old. But aging eventually overwhelms the normal operation of the human body, and that's why we get the diseases and disabilities of old age. And they are awfully bad for us. In an audience of TED or TEDx, it is very controversial to say that I am working on the world's most important problem, but I really am, and this is why. Aging kills 100,000 people every day. That's twice as many as all other causes of death added together. 2/3 of all deaths are from aging. In the industrialized world, it's 90% of all deaths. It's an insane number. And of course, it's not just the death. It's the suffering that goes before the death. That's why I mentioned Alzheimer's disease. I didn't say, who wants to die? I didn't say, who wants to die at age 90? Because you might be a bit confused about that. A lot of people are, and I'm going to come to that in a moment. But none of you want to get Alzheimer's disease, even at age 90. Ultimately, it's all about this. Hands up anyone who wants to be the person on the right. Okay. Even if the person on the left is about to have his head bitten off by a shark. Okay. So it's all about health. It's all about looking and feeling and functioning just as well as you did when you were 25, however long ago you were born. But still, people say these things. You know, people, first of all, they just don't listen. They think that it's all about being in a bad state of health for a very long time. They think that the elimination of aging is a bad idea because they can't work out what they would do, or they can't work out where we would put all the people, or they don't think that it's going to come along in time for them. And of course, they don't care about their children at all. I mean, goodness me. So I think it's all about this. I think it's that aging is so horrible, so scary, that we have found it necessary to put it out of our minds and pretend that it's not horrible at all. And it doesn't matter how we do that, so long as we can, so long as we succeed in tricking ourselves into the idea that aging is a good thing, even though it doesn't look like a good thing. That made perfect sense. It was a rational thing to do until very recently. Because until very recently, nobody had any idea what to do about aging. But now we do. Now we are within a reasonable distance, within striking distance, of developing medicine that really brings aging under the same level of medical control that we have already today for most infectious diseases, like, tuberculosis or whatever. It's like this. People will refuse to think about whether it's actually a good idea to defeat aging because they say, well, it doesn't really matter whether it's a good idea or not, does it? Because we're never going to do it. But the same people, at the same time, will also say that we'll refuse to think about whether it's actually likely that we could do anything about aging anytime soon, because who cares, because it's a bad idea, right? So the pessimism about the desirability and the pessimism about the feasibility join together to perpetuate each other. And that's why I have to give these talks about why it's so important to do this. But of course, in order for me to make any kind of case for this, I have to show you that this part over here, that aging is immutable, really is no longer true. And that's what I'm going to do for the rest of my time. The way that my organization, SENS Research Foundation, is going about combating aging, or developing medicine that will combat aging, is we are developing regenerative medicine for aging. We're interested in not just slowing aging down, slowing down the accumulation of damage in the body, and thereby delaying the age at which we get sick. We're interested in actually repairing that damage, reversing biological age, taking people who are already maybe 60 years old and making them biologically 30 again. That might sound as though it's far harder than just slowing aging down. And indeed, most people who study the biology of aging made that assumption. But a decade or so ago, I realized that that assumption is wrong, and that actually repairing the damage of aging is likely to be much easier than stopping it from happening in the first place. And the way I realized that was essentially by looking at the details. Regenerative medicine is all about restoring the structure of the body, whether it's at the level of the whole organ by replacing an organ with an artificial one, or at the cellular level using stem cell therapy, or at the molecular level, repairing the insides of cells, for example. Aging is all about the accumulation of damage, and damage happens at all of those levels. We have to think about molecular and cellular and whole body damage when we think about aging. And as I explained a moment ago, aging is initially harmless. It is harmless for a long time because the body is set up to tolerate a lot of damage. But it's not set up to tolerate an infinite amount of damage, and that's why eventually we get the diseases and disabilities of old age. Now, the reason that that definition of aging is so useful can be explained using this little diagram. These two approaches that I'm describing here, the gerontology approach and the geriatrics approach, are ways of potentially combating aging, postponing the ill health of old age. And they have both been around a long time, and neither of them work. And neither of them ever will work. Well, not for a very, very long time anyway. The geriatrics approach is an attempt to treat the diseases of old age just like infections, to eliminate them from the body by attacking the symptoms directly. And that's obviously hopeless, because aging is a side effect of being alive in the first place. You can't eliminate it from the body. The gerontology approach says, let's try to slow down the creation of damage so that it doesn't get to this bad level until a later age. But here's the problem with that. We just don't understand the body very well. This here is a simplified diagram of a small subset of what we know about how the body really works. And as you can see, there's no way that we could possibly manipulate this thing to do less of something we don't want it to do, namely the creation of damage, without at the same time breaking it so that it does things that do more harm than good. You know, that's an understatement of the problem. The real problem is that this is a small subset of what we know about how metabolism works, right? And any biologist will tell you that that is completely overwhelmed by the astronomical amount that we don't know about how metabolism works, let alone all the stuff that we don't even know that we don't know. So, you know, there's no way we're going to make this work. But luckily, there is this third approach. This is the regenerative medicine approach. We can call it the maintenance approach. Essentially, what this is, we say, let's not try to interfere with the process where metabolism creates damage, or the process where damage eventually causes the diseases and disabilities of old age. Instead, let us separate those two processes from each other by going in and repairing the damage. And this is the damage. Of course, everything I have said so far has been very dry and theoretical, and maybe it'll work and maybe it won't. In order to actually justify what I've said so far, I have to give you some details. And in the 7.5 minutes I have left, I won't be able to give you very many details, but at least I can start. The great thing about damage is that it's not very complicated. There are only 7 major types of damage that we need to fix. 7 major types of side effect of the body's normal operation that build up throughout life and eventually contribute to the diseases and disabilities of old age. And here they are. And as you can see, they are proper, real, concrete biological phenomena. Cell loss, that simply means cells dying and not being automatically replaced by the division of other cells. You can go down the list and it's the same thing for all of them. But here's the really good news. We can be pretty confident that this list is comprehensive. The reason we can be confident is twofold. First of all, it's been the same list for 30 years. All of these things have been talked about for at least 30 years and researched by people who study the biology of aging. We've come a very long way in biology in that time. You would really have thought that the list would have got longer if, it could have done. But also, the list has not been an explicit list until I came along. I started talking about this more than 10 years ago and challenging people to say, okay, what's missing? Is there anything missing? And no one has come along with anything that can be convincingly added to this list. So that's pretty good news. But only pretty good. The really good news is on the next slide. We have a fair idea how to go about actually fixing all of these things. The reason that this classification of damage is useful is because for each category we can describe a generic therapy that can be used for each of the types of damage to actually implement the maintenance approach to get rid of these types of damage. We can start with cell loss, the death of cells and not compensated by the division of other cells. Stem cell therapy, of course, is exactly what that is there to fix. Stem cell therapy is about replacing cells that the body is not automatically replacing. If we go down this list, we can see the same sort of thing, and I'm going to talk about a couple of them in some detail now. First of all, this one. This doesn't get a lot of attention. Everybody knows that cancer is a major cause of death. Cancer is something that is essentially defined as having too many cells, because cells are dividing when they're not supposed to. But there's another way of having too many cells, which is if cells are not dying when they are supposed to. And most people who don't study aging forget about that because it's not very, high profile. But it turns out it's really important in aging. It's the main reason why we have less good immune systems when we're older. And we're getting somewhere in actually fixing this. The work I'm describing here was not done by my organization, actually. It was done by other people, but it's very much within the theme of what we work on. Essentially, this was an experiment done in mice just very recently, in which they showed how to get rid of these death-resistant cells, which wouldn't die when they were supposed to and which were poisoning the rest of the body. It was a rather artificial experiment with mice that had been genetically modified, so it was only a proof of concept. It doesn't really show us how to develop drugs for this for humans yet, but it was a really good proof of concept. These two mice that you see here, they are the same age, and as you can see, one of them is much happier than the other. The mouse at the bottom is about to die. It's a month away from dying. And the mouse at the top is completely healthy. It's just as healthy as a normal mouse that doesn't have the problem of these accumulating cells. The little graph on the right is one of a dozen or more different experiments that these people did to quantify the biological age of these mice. So this was fantastic. Here, however, is some more early stage work, which is looking at one of the other of these 7 components, the accumulation of molecular garbage inside the cell. This turns out to be incredibly important in some of the most major age-related diseases. Cardiovascular disease, the #1 killer in the Western world. Macular degeneration, the #1 cause of blindness in the elderly. And the problem here is that cells accumulate material because they cannot break it down. This is what happens in cardiovascular disease. White blood cells, normal white blood cells, go into the walls of our major arteries and they process stuff that is stuck there, which is mostly composed of cholesterol. And they're very good at processing cholesterol. Cholesterol itself is not the problem. But unfortunately, the cholesterol is contaminated with a small amount of oxidized cholesterol, which the white blood cells are unable to handle. And that stuff poisons these cells, and they become like this. They become foam cells, full of stuff that they can't process. We figured out that we might be able to use some ingenuity from the rest of nature, not from the human body, but from bacteria in the soil. I realized that the process that turns young people into old people and eventually into dead people is followed by another process that turns dead people into decomposed people. And that process is not anything to do with what's in our genome. It's to do with bacteria in the soil. I realized that we might be able to find out how they break down the human body, and we might be able to use that information to help our own cells, this is a human cell, to break down things that they normally can't. It works. This particular substance here, 7-ketocholesterol, is the thing we're going after. It's the main reason why we get cardiovascular disease. And we found some bacteria using this system called an enrichment culture, which can break it down. These 2 strains of bacteria can break it down really well. We published this, as you can see, 5 years ago. That was the first paper published from work that SENS Foundation did. It's taken us that long to get to the next step, to identify the genes and enzymes that these bacteria are using, and to modify those genes and enzymes so that they work in human cells. We published this just last year, showing that we have succeeded in this. Cells that are given this gene, which is encoding an enzyme to break down 7-ketocholesterol, and modified so that the enzyme is targeted to the correct part of the human cell, those cells are protected from this substance, this toxic substance. That's denoted by the fact that the bar on the right is always taller than the other bars. The other bars are negative controls, where there's no enzyme or there's the wrong enzyme or something. So it's a long project, don't get me wrong. We've done steps 1 through 4 here. Within the next year, I hope that we will be working in mice models of cardiovascular disease, but that will probably take a few years before we can move to clinical trials. But we're getting there. And the key thing is this will be a far, far more powerful therapy for cardiovascular disease than anything that exists today. So we're very excited about this. So I'm going to stop there just to remind you this is what it's all about, stopping you from getting like the person on the right. And this is what I want to leave you with. It's not just me here. I'm a biologist. I get this work done when I can. But ultimately, it's all about public support for all of this. The reason I give so many talks like this, the reason I give so many interviews, the reason that this movement needs to grow is because without public support, not just public philanthropic financial support, but government support, commercial support, we're not going to get this to happen very soon. We need everybody to go out there and advocate, to talk to your friends, talk to your family, talk to your colleagues about how this is the world's most important problem and people are genuinely working to solve it. Thank you very much.
Hang on 1 second. All right, I'm back again. And so I hope you enjoyed that talk. You know, I always like listening to recordings of Aubrey de Grey. He's considered to be one of the top scientists in the field of anti-aging medicine. I've seen him speak several times. And his theory there, if you looked at those 7 things that he listed, are things that we address with the Sizzle products. It's things that Tom has talked about. And the one part of that whole equation, one part that's been missing, according to Aubrey de Grey, was the way to get rid of senescent cells. And while talking to Tom earlier this year, we're going to be having a product come out sometime this year. It'll be called DeBomb. And that's the area that's going to address. So we really will be able to address all 7 of those different areas that Aubrey de Grey was identifying in the video that you just saw. So thanks for watching and thanks for being part of it. Have a wonderful day and let's keep staying healthy. Bye-bye.